I want you to just imagine a scenario for a second. Put yourself right in the room.
Okay, I'm picturing it.
You are standing on the floor of this massive, warehouse-sized laboratory. It's cold, heavily air-conditioned to keep the server banks from overheating.
Right, right. You can almost feel that hum of the servers.
Exactly. And the air smells faintly of ozone and, hot metal. And in the exact center of this room, elevated on a reinforced concrete plinth, is a dense, crystalline structure.
Just sitting there.
Just sitting there. It's perfectly machined, listening under the fluorescent lights, and it's completely surrounded by thick, heavy industrial cabling and what look to you like advanced military-grade radar transmitters.
Which, honestly, sounds like the setup for a high-energy physics experiment.
Yeah.
Something you'd see buried beneath the Swiss Alps at CERN,
That's exactly the vibe. So you're watching the lead engineer. She turns a physical key, hits a highly specific sequence on a digital console, and initiates a 500-megawatt burst of radio frequencies.
500 megawatts.
We are talking about the power output of a medium-sized nuclear reactor, all channeled into this one single crystal. Specifically, the system is pumping 45.01 megahertz of radio frequency.
And then what happens?
Right there, in the center of that crystalline lattice, the air doesn't just shimmer with heat. The actual fabric of space and time twists. It folds in on itself.
Wow.
The geometry of the room distorts, and a spherical void opens up, revealing a destination that just shouldn't be there. You are looking at a traversable wormhole.
A literal bridge through space-time. The ultimate science fiction concept, stripped of its Hollywood magic and brought into the cold, hard realm of the tangible.
For decades, you and I, and really everyone who loves science fiction, we've been told that traveling through a wormhole, a shortcut across the universe, or even across time itself, was relegated entirely to mathematical fantasy.
Like it was a chalkboard exercise.
Yeah. Theoretical physicists would look at the equations and say, sure, the math technically allows for a tunnel, but you'd need magical ingredients to actually build it.
They told us we needed exotic matter.
Exactly. Stuff with negative mass. Things that defy the known laws of physics, and honestly probably don't even exist anywhere in our universe. But we are looking at a stack of sources today that asks a totally different question.
And it's a wild question.
It really is. What if building a wormhole wasn't a physics fantasy? What if it was just a really, really complex engineering problem?
That framing completely shifts the paradigm.
Yeah.
We are looking at a theoretical framework today that takes wormholes off the chalkboard of abstract astrophysics and drops them squarely onto the drafting table of applied material science and radio frequency engineering.
It moves the conversation from, is this forbidden by the universe, to what frequency do we need to tune the antenna to?
Which is just a mind-blowing shift.
The stack of sources we are unpacking today is frankly going to melt your mind a little bit. We are doing a deep dive into a comprehensive series of groundbreaking theoretical physics and engineering papers, published recently in March 2026.
Very recent stuff.
Yeah. The author is an independent Italian researcher named Rodolfo Rossetti. He also publishes under the scientific alias Atom Descendant.
And I have to say, the sheer volume and rigor of what Rossetti has published here, it cannot be overstated.
It's dense.
Incredibly dense. These aren't just speculative, thought experiment essays. This is a massive, multi-part mathematical treatise. We have a foundational paper on what he calls logarithmic spiral tubular wormholes.
Okay, that's a mouthful.
It is, and we have extensive, highly dense mathematical addendums attached to it.
Yeah.
We have raw numerical validation files proving the stability of the geometry.
You think it works?
Right. There's an entire separate paper specifically dedicated to chronodynamics, which is the physics of time travel. And finally, there is a complete geometric and engineering blueprint.
So our mission on this deep dive is to guide you through this labyrinth. We are going to wade through the multi-million-term tensor calculus, and don't worry, we will translate it into English for you.
We promise.
We are going to figure out how Rossetti attempts to completely rewrite general relativity by adding a fundamental twist to the fabric of reality. We're going to understand how he mathematically claims to defeat Stephen Hawking's famous assertion that time machines will always destroy themselves.
Which is a huge claim on its own.
Massive. And perhaps most incredibly for you listening, we are going to explore the literal step-by-step blueprint he provides to build one of these machines.
It really is a journey from the absolute foundational mathematics of space-time curvature all the way down to specific required wattages, crystal lattice structures, and radio frequencies.
But to understand how to build this machine, we first have to understand why the smartest minds in human history previously considered it totally impossible. We can't appreciate the solution until we truly, feel the weight of the problem.
That makes sense.
So let's start with standard general relativity, Albert Einstein, and the dreaded exotic matter. Let's set the stage.
Right, to set the historical stage here, Albert Einstein and Nathan Rosen gave us the very first mathematical description of a wormhole back in 1935.
Right, the Einstein-Rosen bridge.
Exactly.
Yeah.
When they played with the math of general relativity, which, describes how mass and energy warp the fabric of space-time to create gravity, they realized the equations allowed for a topological anomaly.
A weird quirk in the math?
Yeah. Two distinct, far-apart points in space-time could theoretically be connected by a tunnel.
So the math said the door could exist. But from what I understand about that 1935 paper, opening the door wasn't the issue.
No, it wasn't.
The issue was walking through it without getting pulverized. Right?
That was a fatal flaw. In standard general relativity, gravity is strictly the curvature of space-time. Think of a heavy bowling ball sitting on a trampoline.
Okay, the classic physics class analogy.
Right. The fabric curves downwards, drawing smaller objects toward it.
Yeah.
Gravity, in this standard model, always attracts. It always pulls things together.
So it's always trying to close the gap?
Exactly. So if you manage to warp space-time enough to open a tunnel, a wormhole throat, the intense, localized gravity of that warp space wants to instantly slam it shut.
It crushes itself.
It naturally collapses under its own immense weight before even a single photon of light could pass through from one side to the other.
So if I try to visualize this, it's like trying to dig a tunnel through a mountain made entirely of dry, loose sand.
Oh, that's a good way to look at it.
Like the moment you scoop out a handful of sand to make a path, the immense weight of the mountain above immediately causes the sand to rush in and crush the empty space. You can't just dig a hole, you need scaffolding.
Right, you need something holding the walls up.
To keep a wormhole open in standard GR, physicists realized they needed a cosmic equivalent of steel beams. But they couldn't just use regular matter, right?
Regular matter wouldn't work because regular matter has positive mass. And positive mass creates positive gravity, which only adds to the collapsing force.
It makes the sand heavier.
Precisely. To counteract the crushing inward pressure of the wormhole's gravity, physicists hypothesized that you would need stuff with negative energy density.
Negative energy?
Yeah, matter that gravitationally repels instead of attracts. In physics, this requirement is formally known as violating the null energy condition, or the NEC.
The null energy condition essentially says energy cannot be strictly negative. So to keep my loose sand tunnel open, I can't use steel beams. I have to fill the tunnel with magic anti-gravity balloons.
Anti-gravity balloons, I like that.
Balloons that actively push outward with negative mass to hold the sand back. And the massive roadblock for the last century of physics is that nobody has ever found a negative mass balloon in nature.
No, they haven't.
As far as we know, negative mass does not exist.
And that roadblock is precisely why wormholes remain firmly locked in the domain of science fiction and theoretical curiosity. If building the machine requires an ingredient the universe refuses to provide a
The machine cannot be built.
Exactly. The exotic matter requirement was an impassable, fundamental barrier.
And this is where the Rossetti papers completely upend the board. He looks at this impossible requirement for exotic matter, and his solution isn't to go hunting for negative mass.
No, he goes deeper.
His solution is to change the fundamental mathematical language we use to describe space-time itself. He moves us away from standard general relativity and into something called the Einstein Cartan Maxwell framework.
Which is a monumental shift in the geometric foundation of physics. I mean, standard general relativity, the 1915 theory we all learn about, describes gravity purely as curvature.
The trampoline model.
Right. Space-time can bend, it can warp, it can stretch, but Einstein Cartan theory adds a second, equally fundamental geometric property to the fabric of reality: torsion.
Torsion, meaning the literal twisting of space.
Yes. In standard general relativity, the math explicitly assumes torsion is zero. Space-time can curve, but it cannot twist.
It's just a flat sheet bending.
Exactly. But in the 1920s, a French mathematician named Einstein Cartan approached Einstein. Cartan suggested that if you factor in the intrinsic quantum spin of elementary particles, electrons, quarks, things like that, Space-time shouldn't just bend.
Should twist, too.
It should have a twisting property, a microscopic rotation built into the very geometry of the universe.
So wait, Einstein knew about this twisting math back in the 1920s? Why isn't it part of the standard model we teach in high school today? Did Einstein just ignore him?
He didn't ignore him, actually. In fact, they collaborated on it for a while. But at the time, quantum mechanics and the concept of intrinsic particle spin were still in their infancy.
Ah, I see.
Standard general relativity worked perfectly to describe the orbit of Mercury, the bending of starlight, and the expansion of the universe, all without needing the immense mathematical headache of torsion.
So it's just too complicated to bother with.
Basically. Including torsion made the equations astronomically more complicated. And since they didn't have any experimental data demanding its inclusion, Einstein ultimately stuck with his simpler, torsion-free, purely curved model. It was an assumption made for the sake of mathematical tractability.
He essentially said, the universe is complicated enough without adding a twisting fabric, let's keep it simple.
Pretty much.
But Rossetti takes this discarded Einstein Cartan theory, the one that includes both curvature and twisting, and he applies it to a very specific three-dimensional shape. The logarithmic spiral tubular wormhole?
The choice of geometry is the linchpin of this entire theory. The papers detail how Rossetti takes a three-dimensional logarithmic spiral.
Like a snail shell.
Exactly. You can picture the sweeping, graceful curve of a nautilus shell, or the arms of a spiral galaxy, or even the eye of a hurricane. He takes that fundamental shape and mathematically wraps it into a four-dimensional space-time tube.
Okay, my brain is stretching a bit trying to picture four-dimensional wrapping.
It's intense. And he accomplishes this mapping using a highly complex mathematical tool known as the Frenet-Serret frame.
I spent some time staring at the technical notes on the tubular metric derivation, and from what I gather, the Frenet-Serret frame is essentially a way to perfectly describe the movement and orientation of an object traveling along a twisted, curving path.
That's a great way to put it.
Like if you were flying a fighter jet along a corkscrew flight path, the Frenet-Serret frame tracks exactly where the nose is pointing, the tangent vector. It tracks how hard you are pulling up into the curve, the normal vector. And it tracks how the plane is rolling or twisting out of a flat plane, the binormal vector.
That is a phenomenal way to visualize it. It completely captures the intrinsic geometry of the curve. In Rossetti's math, it tracks the curvature, which is denoted by the Greek letter kappa, and the geometric torsion, denoted by tau.
So curvature and twist.
Right. By wrapping a space-time tube around this nautilus shell spiral core, the mathematical torsion of the actual space-time, the Einstein Cartan twist, is directly, inextricably tied to the physical geometric twist of the spiral shape itself. You cannot have this shape without having the torsion.
Which leads us directly into the first massive, paradigm-shattering breakthrough in these papers, the Rossetti geometric autonomy theorem.
The autonomy theorem.
Yeah, the name sounds like a mouthful, but the physical implication for our loose sand tunnel is absolute game-changing.
It is the mathematical proof that the existence of this specific logarithmic spiral wormhole is completely decoupled from any external supporting fields.
Wait, meaning what?
If you look at the governing equation for the wormhole throat equation 22 in the primary text, it demonstrates that the throat is structurally self-sustaining. The wormhole holds itself open. It is a topological necessity of the spiral geometry.
Meaning, we can throw the anti-gravity balloons in the trash. We don't need exotic matter.
The requirement for exotic matter drops to absolute zero.
Well,
to see why, we have to look closely at how the paper dissects the null energy condition. Equation 11 breaks the massive tensor equation into distinct physical blocks. First, you have the pure curvature sector.
That's the part that represents standard Einstein gravity, the tendency for the tunnel to collapse and crush you.
Correct. If you only have curvature, as standard general relativity assumes, this sector demands negative energy to counteract the collapse. But then Rossetti introduces the torsion connection sector.
The twisty part.
Yes, this block of the equation encapsulates the energy stored in the self-interactions of the twisting torsion field.
And reading through the paper, he refers to this torsion sector as a repulsive geometric engine. Because of the way the math works, specifically the quadratic terms in the torsion tensor, the physical twist of the space-time actually generates an effective positive outward pressure.
It pushes back.
The geometry itself pushes back against the gravity.
That is exactly what is happening mathematically.
So if standard GR is my crushed sand tunnel needing impossible anti-gravity balloons to hold the walls up, Rossetti's torsion model is totally different. If I picture taking a soaking wet beach towel.
Okay, a beach towel.
You lay it flat on the grass, and it has zero structural integrity. It just lies there flat. But if you grab both ends and start twisting it, wringing the water out, the more you twist, the tighter and more rigid the towel becomes.
Right, it bunches up.
If you twist it tightly enough, it forms a solid, hard knot. You can pick it up, and it holds its own shape in the air simply through the tension of the twist. You don't need to stuff wire or balloons inside the towel to make it rigid. The act of twisting it provides all the outward structural integrity you need.
The wet towel is the perfect mental model for the geometric engine. The twisting of the space-time manifold to geometric torsion generates a literal physical pressure that pushes outward. It perfectly counteracts the crushing inward force of the curvature.
So the equation balances out.
Exactly. The null energy condition isn't just violated by some magical substance. As Rossetti writes, it is transmuted by the torsional pressure of the non-Riemannian connection. The century-old search for exotic fluids is rendered totally obsolete by a deeper understanding of geometry.
But this immediately forces me to ask a massive historical question.
Go ahead.
We established Einstein and Nathan Rosen wrote their wormhole paper in 1935. Einstein Cartan proposed the idea of space-time torsion in the 1920s. If the solution was just a matter of combining those two ideas, adding twist to the math of the tunnel, why did it take a century?
That is the big question, isn't it?
Yeah. Why didn't Einstein or Rosen or Stephen Hawking just figure this out? Why did it wait until an independent researcher in 2026?
Well, the delay wasn't due to a lack of imagination. It was due to a severe fundamental lack of computational power.
Really? Just computers?
Computations, yes. The sheer, overwhelming complexity of the mathematics involved in Einstein Cartan theory is difficult to overstate. When you introduce torsion into the gravitational field equations, specifically when you add non-minimal couplings between the affine connection and the torsion tensor, the equations don't just get a little harder, they explode in size.
What do you mean by explode? Are we talking about, like, a page of math, 10 pages?
We are talking about multi-million term expansions.
Yeah.
Millions. In standard general relativity, if a graduate student needs to calculate the Einstein tensor for a simple black hole by hand, it might take them a week of grueling hyperfocus algebra on a chalkboard.
Just for a standard black hole.
Right. But in the Einstein Cartan Maxwell framework, applying it to a complex four-dimensional tubular spiral metric, doing that symbolic calculus by hand is functionally impossible for a human lifespan.
A human lifespan, wow.
The margin for dropping a negative sign or messing up a tensor index along the way is basically 100%. You will make a mistake.
Ah, okay. This explains why the papers constantly reference a software suite called Ext. It pops up in the methodology sections over and over again.
Yes, exact. It is a highly specialized suite of packages designed for automated tensor algebra, usually run within the Mathematica software environment.
So it's heavy-duty math software.
Exactly. Rossetti explicitly, repeatedly acknowledges that this theoretical breakthrough was only made possible by the recent, long-term development of these symbolic tensor calculus tools. He needed digital computational infrastructure capable of handling, factoring, and simplifying these multi-million term algebraic expansions without a single human error.
So Einstein simply didn't have a supercomputer to solve these equations. He had a pencil, a chalkboard, and his intuition.
That's it. So saying Einstein should have solved this is like asking someone to render a modern 4K 3D video game on a wooden abacus.
Right.
The theoretical fragments might have been floating around in the 1920s, but the sheer processing power required to actually build, test, and prove the geometric engine model mathematically just didn't exist until the last few years.
Exactly the case. Rossetti utilized this modern computational brute force to factorize these massive equations into physically meaningful blocks. He forced the computer to prove that the twist of the tau of the torsion perfectly mathematically balances the collapse of the curvature.
And the computer proved him right.
Okay, so think about what this means for you, the listener. It means a traversable wormhole tunnel can theoretically exist right now in our universe without requiring impossible magic matter. The physics allow it.
The door is open.
But just because a tunnel exists doesn't mean you can pack your bags and fly a spaceship through it.
Very true.
I mean, a volcano is technically a tunnel into the center of the Earth, but jumping in is a one-way trip to becoming ash. What actually happens when a particle or a spaceship or a human being tries to enter this tightly twisted space-time?
You've hit on the exact reason why proving the wormhole exists is only half the battle. This brings us to the second major conceptual pillar of our deep dive. And frankly, one of the most mathematically rigorous proofs in the entire collection of papers.
Which is?
The torsional shield theorem.
The torsional shield theorem. I won't lie, the name alone sounds like a tactical command from a space opera, like raise the torsional shields.
It does sound like science fiction, but the foundation here is pure, unforgiving differential calculus.
And math doesn't lie.
Right. To prove a wormhole is truly traversable, you can't just prove the door is open. You have to prove the frame of the door is dynamically stable when someone walks through it.
What happens to the door frame?
Well, if a spaceship enters the throat of a wormhole, the sheer mass and energy of that ship acts as a radial perturbation.
Disturbance.
Exactly. In older standard models, the math showed that this tiny perturbation is often enough to destabilize the incredibly delicate balance of the throat.
Yeah.
The gravity reacts to the mass of the ship, pinches off instantly, and crushes the vessel into fundamental particles.
Like trying to push your finger through a giant soap bubble.
Yes.
The moment the mass of your finger touches the surface tension, the whole delicate structure pops. It's too fragile.
Exactly. The instability was a death sentence. So Rossetti derives what he calls the radial master equation to rigorously study how the spiral wormhole responds to these fluctuations.
He tests the bubble.
He forces the math to ask, what happens when I push on the walls of this twisted tunnel? And the answer he finds is genuinely astonishing. The effective radial potential, which is the mathematical boundary governing how the throat responds to being pushed, is composed of a standard geometric part and a torsional part.
And as you get closer and closer to the actual throat of the wormhole, where the Nautilus spiral radius reaches its absolute tightest point, the mathematical limit does something extreme.
It diverges to positive infinity.
Infinity.
Yes. The torsional contribution to the effective potential, which is driven by that incredibly tight intrinsic twist of the spacetime, creates an impenetrable, repulsive barrier. The paper states unequivocally that it strictly forbids unstable modes.
So it won't collapse.
Mathematically, it proves that the throat of the wormhole is dynamically protected by an infinite torsional barrier. It actively immunizes the throat against catastrophic collapse. The harder you push on the walls, the infinitely harder the twisted space pushes back.
So instead of a fragile soap bubble that pops when you touch it, the throat of this wormhole is more like a solid titanium bank vault door. It cannot be crushed.
It's rock solid.
But wait, if I'm thinking about this logically, if there is an infinite repulsive barrier at the narrowest part of the throat, how does anyone or anything actually get through it?
That is the catch.
Doesn't an infinite barrier mean the tunnel is totally blocked?
This apparent paradox is where we have to shift our focus to the numerical validation addendum of the papers, which is absolutely fascinating.
The simulation data.
Right. Rossetti didn't just trust the symbolic algebra to tell him the whole story. He built a pure physics numerical suite to integrate the exact geodesic equations. He wanted to simulate the actual physical paths a particle would take if it tried to fly into this geometry.
I noticed the methodology section for the numerical simulation was incredibly detailed. The paper explicitly mentions using a specific algorithm to map these paths, called the DOP-853 Runge-Kutta algorithm.
Yes, he highlights that for a reason.
Why go out of his way to highlight the specific algorithm?
Because in theoretical physics, how you simulate the math is just as important as the math itself. The Runge-Kutta algorithm is a highly advanced, highly precise method for solving differential equations.
How precise are we talking?
Think of it like slicing the continuous flight path of a spaceship into trillions of microscopic freeze-frame steps. At each microscopic fraction of a second, the algorithm calculates the exact gravitational and torsional forces acting on the ship, predicts where it will be in the next fraction of a second, and moves it there.
Frame by frame by frame.
Exactly. And Rossetti ran these massive simulations with an energy conservation margin of error set at 10 to the negative 13th power.
10 to the negative 13th. That is machine-level fundamental limit precision.
It is absolute precision.
Right. He's basically stamping the paper saying, the weird stuff happening in these simulations is not a glitch in my Python code. This is real, mathematically guaranteed physics.
That's exactly the statement being made. And what this ultra-precise numerical integration revealed is that the geometry of the wormhole is inherently structurally asymmetric.
Asymmetric, meaning the front door of the wormhole behaves fundamentally differently than the back door.
Precisely the case. The geometric torsion is maximized on the tightly coiled inbound side of the spiral. As you approach the entrance, the twist gets tighter and tighter, creating that massive repulsive wall.
The barrier.
Right. But as you cross the mathematical threshold of the throat and move to the outbound side, the torsion begins to asymptotically vanish. The twist unwinds.
The phase space portrait he generated in the addendum to visualize this is just wild. He plots the trajectory of thousands of virtual particles trying to fly into the wormhole at different speeds.
And what happens to them?
Well, if you look at the red curves on that plot, which represent the inbound trajectories, you see them approach the throat. They hit that extreme, diverging, torsional gradient. Their forward velocity violently drops to zero, and then they are aggressively reflected backward.
They bounce off.
They literally bounce off. The paper actually calls it a white hole force shield.
A white hole being the theoretical opposite of a black hole.
Exactly. An object with such intense outward space-time flow that you can never enter it. You can only be expelled by it.
The inbound side acts exactly like a macroscopic white hole.
Cool.
But contrast that with the green curves on the plot. Those represent outbound trajectories that originate just past the center of the throat.
The ones that started inside.
Right. Those particles experience a monotonically decreasing potential. They aren't reflected at all. They are granted smooth, free passage to spatial infinity on the other side.
Okay, let me try to map a real-world visualization onto this so we can really feel what this asymmetric geometry means.
I love your analogies. Go for it.
Imagine you are walking through an airport and you encounter one of those long, flat moving walkways.
Oh, yeah.
If you try to run onto the moving walkway from the wrong end, the exit end, the intense friction of the rubber belt moving against you, combined with the physical force of the machinery, violently pushes you back out onto the carpet.
Right, you get thrown back.
No matter how fast you run, the physical system rejects you. You cannot enter. But if you were to somehow be dropped right into the very center of the walkway, moving in the correct outward direction, you just glide effortlessly to your destination. The system carries you.
The moving walkway is an excellent physical analog. It creates a macroscopic chronological asymmetry. The twisting fabric of space-time itself enforces a strict one-way flow of traffic at a fundamental geometric level.
But I have to push back on this because I'm putting myself in the shoes of the pilot trying to fly this mission, and I am stuck.
Why are you stuck?
If the inbound side violently physically reflects any ship trying to enter it, how is this traversable at all? If I fly my spaceship up to the entrance of this wormhole, do I just bounce off the white hole force shield like a bug hitting a windshield?
That is the critical paradox of the entire structure. And it highlights a massive realization. This isn't just a natural space weather phenomenon you can accidentally fly into, like in Star Trek. It requires active, highly precise engineering to traverse.
You can't just fly through it.
You cannot simply fall into this wormhole from the outside. The extreme torsional gradient will absolutely reject you. To traverse it, you must somehow bypass the reflection point entirely.
How is that physically possible if the shield is infinite?
By controlling the ignition sequence from the inside.
From the inside?
Yes. This connects directly to the macroscopic engineering blueprint we're going to discuss later. To use this machine, you don't build it in space and fly toward it. You build machine around the ship. You have to ignite the wormhole and navigate the specific coordinates of the spiral in a way that places your physical mass on the outbound side of the torsional barrier at the exact millisecond of macroscopic expansion.
You have to ride the wave of the spatial expansion outward rather than fighting your way inward against the barrier.
Exactly.
Oh, wow. Okay, my mind is slightly blown by that. So you aren't flying into an open door. You are sitting at the exact dead center of the mechanism when the engineer turns the key. And the asymmetric geometry effectively detonates outward, pushing you smoothly to your destination while putting up a wall behind you.
It's a highly orchestrated, incredibly precise topological maneuver. But the absolute key takeaway from the torsional shield theorem is that once the throat is triggered and opens, it will not collapse and crush you. The infinite torsional barrier guarantees that the geometry actively protects itself from the mass of the traveler.
Okay, let's take stock of where we are, because we've covered a lot.
We have.
We have a mathematical tunnel that doesn't need impossible magic matter, thanks to the twisting pressure of the geometric engine.
Yeah.
And we have a tunnel that is guaranteed not to collapse and crush us, thanks to the asymmetric one-way torsional shield.
Check.
We have a stable, open, safe geometric passage.
Which brings us to the single most controversial, profound, and physics-breaking claim in the entire collection of Rossetti's papers.
Yes. We need to pivot to the elephant in the room. Time travel, and the legendary physicist who said it was absolutely, fundamentally, mathematically impossible.
We are talking about Stephen Hawking.
Right. Section 3 of our stack of papers is entirely dedicated to chronodynamics. And Rossetti doesn't mince words here. The text explicitly, boldly claims to have completely destroyed Stephen Hawking's chronology protection conjecture.
Destroyed. It is a massive, incredibly audacious claim for any physicist to make. To truly understand why defeating Hawking is such a monumental deal, we need to dig deeply into what Hawking was actually arguing back in the 1990s.
What was his problem with time travel?
Well, Hawking, like many physicists, knew that the equations of standard general relativity technically allowed for paths through spacetime that loop back on themselves.
These are known in physics as CTCs, right? Closed time-like curves, the scientific terminology for a working time machine.
Yes, a closed time-like curve is a path through space and time, where, if you follow it, you eventually arrive back at the exact spatial coordinates and the exact moment in time that you started. You returned before you left.
The classic time loop.
But Hawking fundamentally hated this idea. He believed that nature, at a fundamental level, must abhor a time machine, because time machines introduce paradoxes that break the universe.
Like the grandfather paradox.
Exactly. You go back in time, accidentally prevent your grandparents from meeting you were never born, meaning you could never go back in time.
Yeah.
It breaks causality. It breaks logic.
So Hawking proposed the chronology protection conjecture. He basically laid down a law that said the laws of physics must conspire to prevent time machines from ever operating.
But Stephen Hawking was a mathematician. He didn't just say, I don't like it. He provided a rigorous mathematical mechanism for why any time machine would immediately fail.
What was a failsafe?
That fail-safe mechanism relies heavily on quantum mechanics. Hawking argued that the moment a wormhole is configured to act as a time machine, the exact nanosecond a closed time-like curve is about to successfully form the geometry, creates a temporal boundary known as a Cauchy horizon.
What happens at a Cauchy horizon? Why is it a death sentence for the wormhole?
Because of the quantum vacuum. In quantum physics, empty space isn't actually empty. It is constantly boiling with quantum vacuum fluctuations, tiny virtual particles that are constantly popping in and out of existence in fractions of a microsecond.
Just background static.
Basically, they borrow energy from the universe, exist for a moment, and annihilate each other. Hawking pointed out that if you have a time machine, these virtual particles will start traveling through the wormhole. Because it's a time machine, they exit the wormhole in the past, travel through normal space, and then enter the wormhole again at the exact same moment they first entered.
Oh, I see the problem. The particles are meeting their past selves. It's a loop. They pile up on top of themselves.
They pile up infinitely. The quantum vacuum energy diverges to infinity at the Cauchy horizon. It feeds back on itself, doubling, quadrupling, compounding instantaneously until the infinite energy density instantly destabilizes the metric and vaporizes the wormhole.
So it destroys
The
itself.
time machine physically blows itself up the exact millisecond it tries to turn on.
Let me use an audio engineering analogy for this because I think it perfectly captures the violence of what Hawking described.
Okay, let's hear it.
It's exactly like bringing a live microphone too close to an amplifier speaker.
Oh, I know that sound.
Right. The mic picks up a tiny bit of ambient room noise. It sends that noise to the amp, the speaker plays it slightly louder. The mic picks up that louder sound, sends it back to the amp to be played even louder, and within a fraction of a second, you get that ear-shattering, infinite screech of audio feedback that physically blows out the speaker cone.
The feedback loop.
Hawking is saying the quantum vacuum is the microphone, the wormhole is the speaker, and the time loop causes a quantum feedback screech that instantly blows out the fabric of spacetime.
The microphone feedback loop is exactly how Hawking's semi-classical gravity mechanism operates. He mathematically argued that quantum field theory predicts this infinite energy divergence, thus forever protecting the chronology of the universe. Time travel is permanently canceled by quantum feedback.
But Rossetti looks at Hawking's math, and he says Hawking was wrong, or, well, more charitably, that Hawking was working with an incomplete set of architectural blueprints.
Rossetti solves the feedback problem via what he terms the torsional discharge limit. And to understand it, we have to trace everything back to the Einstein Cartan framework we discussed earlier.
The twisting math.
Right. Hawking based his entire chronology protection conjecture on a standard torsionless Riemannian background, a spacetime that only dens in curves, but does not twist.
He based his proof on the flat trampoline, completely ignoring our wrung-out wet towel.
Exactly. But Rossetti mathematically proves that when you elevate the spacetime manifold to include non-Riemannian geometric torsion, the twist of the space actively couples to those boiling vacuum fluctuations. The geometric torsion begins to act as a literal geometric capacitor.
A capacitor in an electrical circuit stores excess electrical energy. So you're saying this twist in space-time is absorbing and storing the quantum feedback loop.
It absorbs it, and more importantly, it caps it. The theoretical framework introduces a natural ultraviolet, or UV, cutoff.
What does that do?
If we look deep into the paper on chronodynamics, Rossetti breaks down the behavior of the Dirac propagator, which mathematically describes how these quantum particles move within a highly torsional background. Because the intense torsion introduces what is called a topological mass gap, the mathematical integration of those vacuum energy modes physically cannot extend to infinity.
Wait, I need to stop you there because topological mass gap is extremely dense. We need to break that down. What does a mass gap actually mean in this context?
In quantum field theory, a mass gap essentially means there is a minimum energy threshold required to create a particle, or a maximum limit to its momentum. In this specific wormhole context, the extreme twisting geometry of the spacetime itself creates a physical ceiling on how much energy these virtual particles can possess.
A hard limit.
A hard mathematical limit. The infinite feedback loop is physically capped, mathematically choked off, by the geometry. The paper shows that the renormalized stress energy tensor the calculation of all that feedback energy scales exactly with the torsion. Specifically, it scales to the torsion parameter raised to the fourth power. It hits a limit. It does not diverge to infinity.
Okay, so extending my audio analogy. If Hawking's model is the microphone causing an amp-blowing screech of infinite volume,
Yes.
Rossetti's torsional discharge limit is like installing a heavy-duty automatic surge protector or a noise-canceling circuit in line with the speaker. As the feedback loop starts to build up and get louder, the physical twist of space-time acts as a volume governor. It physically caps the volume.
It stops the screech.
It safely absorbs the excess feedback energy, storing it in the geometric tension so the music can keep playing and the amplifier doesn't explode.
That analogy is spot on. The infinite quantum energy is fundamentally choked off before it can destabilize the metric of the wormhole. Rossetti shows that the exact 16-term symbolic expansion, which in Hawking's math blows up to infinity, contracts perfectly into a finite bilinear invariant.
The math checks out.
The mathematical limit is a finite number. The energy is contained. The time machine does not blow up.
It's hard to convey just how staggering a claim this is. Reading the paper, Rossetti writes, Hawking's chronology protection conjecture is not merely bypassed, it is structurally and mathematically destroyed by the inclusion of non-Riemannian torsion.
Those are fighting words in the physics community.
Seriously, but I want to be absolutely 100% crystal clear with you on the implications of this. When we say time machine, we're talking about literal time travel here, right?
Yeah, literal time travel.
We aren't just talking about a shortcut through space where I get to the Andromeda galaxy really fast. We mean traveling backward into the chronological past.
We do. Once Hawking's quantum limit is defeated and the stability of the throat is guaranteed, the paper details how bidirectional time travel is actively achieved via a macroscopic mechanism called frame dragging.
Frame dragging. What is happening to the ship at that point?
It involves the immense rotation of the electromagnetic gauge field within the wormhole. By creating a highly specific rotational coupling between the electromagnetic energy and the geometric torsion, the wormhole induces a massive, non-vanishing T-phi component in the stress energy tensor.
I'm going to need you to translate a non-vanishing T-phi component into something a human can visualize, because you lost me.
Right, sorry. In physics, we use the concept of a light cone to represent all possible future paths for an object.
Yeah.
It represents the absolute boundary of causality. Forward in time is always pointing up in the cone.
Okay, the cone points to the future.
By rotating the massive electromagnetic field inside this highly twisted spacetime, the geometry physically grabs those local light cones and tilts them.
It tilts the future.
It tilts them so violently and so intensely that a path pointing straight forward into the wormhole throat actually points backward into the chronological past of the outside universe.
Mm-hmm.
It specifically mechanically allows for the creation of closed time-like curves. The ship travels forward, but arrives in the past.
Okay, let's take a deep breath here, because we have covered an unbelievable, almost overwhelming amount of theoretical ground today.
It's a lot to process.
Think about the journey we've just mapped out for you. We started with multi-million-term tensors run on supercomputers. We proved that adding twist torsion to Einstein's gravity eliminates the need for impossible magic matter.
Yes.
We proved that this twisted structure naturally forms an asymmetric one-way shield that repels collapse. And we just proved that the same torsion acts as a cosmic surge protector, absorbing infinite quantum feedback, defeating Stephen Hawking, and allowing light cones to tilt into the past.
It is a totally enclosed, mathematically verified end-to-end framework. He calls it the Rossetti master model.
But math on a piece of paper or, code in a supercomputer is one thing. As beautiful as equation 22 might be to a physicist, you cannot write an equation into the past.
No, you cannot.
Which brings us to our final document in the stack, and honestly, the one that made my jaw hit the floor. Section 4, the macroscopic blueprint. How do we actually physically build one of these machines in the real world?
This is the moment the deep dive transitions from the esoteric world of theoretical differential geometry into the gritty, applied world of macroscopic RF engineering and condensed matter physics. The final paper in the suite is titled Self-Sustained Einstein Cartan Wormholes, a complete geometric and engineering framework.
And what's wild is that it doesn't just offer vague guidelines like, build a big laser. It gives us the specific physical medium, the exact material required to warp space. It says we need to construct a core out of a yttrium iron garnet or YIG Kagome lattice.
Yes. Yttrium iron garnet, or YIG, is a synthetic garnet. It's a crystal with highly specific, well-understood magnetic properties. It is actually heavily used today in mundane microwave and telecommunication devices.
Like cell towers.
Exactly. And a Kagome lattice refers to the specific geometric arrangement of the atoms within that crystal. It's a pattern of corner-sharing triangles resembling the Star of David.
Why this specific crystal? Are we venturing away from quantum physics and getting into, new age crystal healing magic here? Why YIA?
Not magic at all. It's pure condensed matter physics. The atomic arrangement of the Kagome lattice causes something called geometric frustration. The magnetic spins of the atoms can't easily settle into a simple, boring pattern. Because of this tension, the mechanism relies on triggering a phenomenon called Frulich condensation within the magnetic domains of the YIG lattice.
Okay, let's unpack Frulich condensation. For someone who isn't a solid-state physicist, what is happening to the crystal?
Normally, the intrinsic quantum spins of the electrons inside any material are messy. They are localized, pointing in somewhat random directions, canceling each other out. But under very specific conditions, if you pump an immense amount of resonant energy into the system, you can force all of those individual chaotic quantum spins to suddenly align macroscopically.
They line up.
They lock together. They enter a coherent quantum state, acting not as trillions of tiny spins, but as one single, giant, unified macrospin.
Like watching a massive chaotic school of thousands of fish suddenly simultaneously turning and swimming in the exact same direction as one giant entity.
Exactly that kind of emergent coordination. And here is the vital connection back to the math in the Einstein Cartan framework. Macroscopic spin density is the direct physical source of space-time torsion.
Because torsion is twist.
Remember, torsion is twist. By forcing the spins of the trillions of electrons in the YIG lattice into alignment, you are directly physically generating the macroscopic geometric torsion required to twist space-time and open the wormhole throat.
But wait, I see a massive scale problem here. An electron is infinitesimally small. Its quantum spin is microscopic. A wormhole that a spaceship or even a small drone could travel through is huge.
Right.
How on earth do you bridge the gap between microscopic quantum mechanics and macroscopic planet-scale gravity? Gravity is famously, notoriously weak on a quantum scale.
This is where the absolute genius of the engineering blueprint shines. The paper derives what Rossetti calls a geometric amplification factor.
Yeah.
And it's not just a random placeholder number designed to make the math work. It is derived directly from the physical constraints of the YIG crystal itself.
Let's look at the numbers. The paper specifically highlights the lattice constant of the crystal and the magnetic domain wall thickness.
Yes, if you look at the material science of yttrium iron garnet, the ratio of its lattice constant to its domain wall thickness is roughly 0.012. When you plug that exact physical constraint, along with the required winding parameter for the radio frequency pump, into the complex integral for geometric torsion, the math naturally yields an exponential amplification factor of 10 to the 44th power.
10 to the 44th power. That is a 1 followed by 44 zeros. That number is almost incomprehensibly large.
It has to be.
Yeah.
It perfectly bridges the 40 order of magnitude gap between the extreme weakness of gravity and the immense strength of the electromagnetic force holding the crystal together. As Rossetti notes in his conclusion, this amplification is not numerology. It is a rigorous derived consequence of YG material science. The crystal naturally acts as a quantum to macroscopic amplifier.
Okay, so I'm picturing the room again. We have our massive, perfectly machined YIG crystal. We know we need to force all the electrons to swim in the same direction to create the torsion. How do we turn it on? Where is the ignition switch for a time machine?
The ignition requires a massive RF radio frequency transmitter. It needs to pump immense electromagnetic energy into the crystal to trigger that Frulich condensation. And the paper doesn't just say use radio waves, it gives us the exact, specific tuning required.
I have the schematic right here. It says the RF pump must be tuned to a resonant frequency of exactly 45.01 megahertz, and the cabling must be impedance matched to 482.45 ohms. Reading this, it feels less like a theoretical physics paper and more like an instruction manual for an amateur ham radio operator.
The specificity is remarkable. It leaves no ambiguity. But there is a significant hurdle. The critical ignition threshold, which is the sheer amount of raw power required to push the crystal past the tipping point, trigger the Frulich condensation, and dynamically expand the throat into a macroscopic size, is 500 megawatts of RF power.
Okay, I have to stop here and push back on the reality of this. I looked up these power requirements. 500 megawatts is roughly the total output of a medium-sized commercial nuclear power plant.
It is a lot of juice.
It's the amount of power drawn by an entire small city. Is this actually something humanity can build? Or are we just replacing the impossible exotic matter requirement with an equally impossible needed Dyson sphere power requirement? Are we pretending this is a garage project?
It is definitively not a garage project, but we absolutely need to contextualize the scale here. 500 megawatts of continuous 247 power is massive. But the blueprint specifies 500 megawatts of pulsed RF power.
Pulsed, not continuous.
Right, and pulse power of that magnitude is well within the current capabilities of modern human engineering. Advanced military radar installations, massive phased array early warning systems, and particle accelerators like the Large Hadron Collider deal with transient power levels in this exact regime during pulsed operations.
So to build this, you need state-level infrastructure or the backing of a massive, well-funded corporate laboratory. But crucially, you do not need alien technology. You don't need a fictional energy source. It is a monumental leap from the old standard models, which seriously suggested we would need the total energy output of an exploding star or a black hole just to open a wormhole the size of a golf ball.
That is the paradigm shift. It brings the energy requirement for a time machine down from impossible stellar scale engineering to extremely expensive, highly complex terrestrial defense project. It is achievable with today's technology.
That realization is chilling. But here's the kicker, the final piece of the puzzle. Let's say a government or corporation actually does it. They build the giant YIG lattice. They hook up a dedicated miniature nuclear reactor. They pump 500 megawatts of 45.01 megahertz radio waves into the crystal, and boom, the space-time twists, the throat opens. We have our macroscopic, stable wormhole. What happens when the power bill comes due? What happens when we have to shut the nuclear reactor off? Does the wormhole instantly slam shut and sever the connection?
This brings us to the final and perhaps most mathematically elegant concept in the entire stack of papers, topological hysteresis.
Hysteresis. I recognize that word from high school physics, specifically regarding magnetism.
And magnetism is exactly the right context to understand it. Once the 500 megawatt RF pump achieves the dynamic threshold and the throat expands to its macroscopic radius, the physical system stores that immense twisting torsional energy directly within the macroscopic spin alignment of the space itself. The math dictates that the hysteresis term becomes globally locked in.
So if I compare it to magnetizing a piece of iron, if I take a normal iron nail, I can use an electric current to wrap a magnetic field around it. The microscopic domains inside the iron align. But the magic is, once I turn off the electricity and remove the wire, the iron nail remains a permanent magnet. It remembers its polarized state.
That is a perfect physical analogy. The space-time itself remembers its open, twisted state. The final paper proves mathematically that even if the 500 megawatt power source is completely physically severed, if the RF pump is reduced to absolute zero, the logarithmic argument governing the radius of the throat remains strictly greater than 1.
Meaning
the wormhole is dynamically self-sustaining. It achieves a state of global topological inviolability. Once you force it open with that initial nuclear pulse, it stays open, permanently, without requiring a single additional watt of power input.
Okay. Let's pull all the way back and look at the massive reality-bending journey we just took. We started with a pile of incredibly dense, hyper-complex mathematical proofs published by an independent researcher in March 2026. And from that math, We extracted a coherent, tested narrative that literally rewrites the fundamental laws of gravity.
We moved from the highly abstract to the deeply applied.
Ugh.
We completely bridged the gap.
Exactly. We learned that by adding the concept of twist geometric torsion to Einstein's standard curves, the century-old need for impossible, fictional, exotic matter completely disappears. The twisted space naturally holds itself open. We found out that this twisted structure naturally forms an asymmetric, infinite barrier that repels collapse and acts like a one-way moving walkway, ensuring you don't get crushed.
We saw how that exact same torsion acts as a cosmic surge protector, placing a physical cap on quantum vacuum fluctuations, safely absorbing infinite energy, and definitively defeating Stephen Hawking to allow for backward time travel.
And we ended up with a literal, actionable blueprint. A YIG Kagome crystal lattice, a highly specific 45.01 megahertz radio frequency, and a massive but attainable 500 megawatt power pulse. Think about why this matters to you, the listener, driving your car or sitting at your desk right now. It matters because it represents the moment where the concept of time travel and wormholes potentially transitions from theoretical physics chalkboards to applied materials science and RF engineering laboratories. It means humanity might actually be capable of building one of these.
It radically shifts the fundamental question from, is this even allowed by the universe, to when do we secure the funding to start construction?
And that leads me to a final lingering thought, something I have not been able to shake since reading about the concept of topological hysteresis. The idea that once you dump that 500 megawatts into the crystal and open the wormhole, it stays open permanently, even after the power plant is dismantled. It just sits there, self-sustaining forever.
A permanent, indelible topological scar in the fabric of spacetime.
Exactly. So if these logarithmic spiral wormholes can become completely self-sustaining and stay open forever without any powder source attached to them, could there be ancient, dormant, macroscopic wormholes already floating silently in our universe? Remnants of cosmic events or ancient engineering hiding perfectly within specific magnetic fields? Just sitting there, waiting for us to turn our antennas to the sky and map their faint 45 megahertz RF signatures.
Now that is a profound question to leave on.